This is the video for Lewis dot of atoms and ions. By the end of this video, you should be able to write the Lewis dot diagram for atoms and ions. To do so, you should have your pencil, a periodic table, and the Lewis dot of atoms and ions video sheet. Starting at the beginning, Lewis dot diagrams. Lewis dot diagrams are used to show where the valence electrons are located. Let's do some examples. Silicon is located right here. Silicon has 4 valence electrons. Gallium is located right here. It has 3 valence electrons. And potassium is located down here. It has 1 valence electron. Now, what is an easy way you can figure this out? The trend is, going across the top, this column has 1 valence electron, this column has 2. Everybody in the middle also has 2 valence electrons. Everybody at the bottom has 2. This column has 3. This column has 4. This column has 5, 6, and 7. From neon on down has 8. But helium, he's an exception, he has 2. So determine the number of valence electrons. You count 1, 2, 3, 4, 5, 6, 7, 8, with the exception of helium has 2, everybody in the middle has 2, and everybody down below has 2. So how are we going to use this? Let me get rid of this. The first 2 valence electrons fill up s orbitals. All the electrons after that fill up p orbitals. So to do silicon, you would have the silicon symbol, and then you want to show where the 4 valence electrons are located. The first 2 are s electrons. They're going to go on the same side. We have 2 more. They're going to go in the p's. They're going to spread out, 1 and 2. This is left over from last year when you would have said 3s has 2 electrons, and the 3p's, there's 3 orbitals, and the electrons spread out before they pair up. That's how you get this order. For gallium, gallium is Ga. The first 2 electrons go side by side. They're the s ones. The third and last valence electron is a p. It goes by itself. Potassium is K. He has only 1 valence electron. He is going to go here. In general, your order for filling should be the following. You're going to put down whatever the symbol is. You're going to put the first 2 electrons side by side. They're the s. Then you're going to do the third, the fourth, and the fifth. So you see how the p electrons spread out? Then the 6th, the 7th, and the 8th electron. You also need to know how to do this for ions. To do that, you're following the octet rule. The octet rule is the tendency of an atom to gain or lose electrons until it has a full outer energy level. That means it's going to have 8 electrons on the outermost energy level. Remember, when you lose electrons, you're going to become a positive ion because you've lost negative electrons. When you gain electrons, you're going to become a negative ion. That's because you gained additional negative electrons. Let's try doing the Lewis dot diagrams for these. First, we want to find out how many valence electrons they have. So taking a look at our periodic table, let's take a look at our trends. Sodium is here, oxygen is here, and nitrogen is here. Sodium, being the first column, has 1 valence electron. Counting across, oxygen has 6. And nitrogen, who is right here, will have 5 valence electrons. Now sodium, as an atom, will have 1 valence electron. Oxygen as an atom would have had 6. We're going to put the first 2 together, then the third, the fourth, the fifth, and then the 6th electron. And nitrogen has 5. You put the first 2 together, then the third, fourth, and fifth. This is what the atom looks like. Now, is it going to lose or gain electrons? For sodium, it can either lose the 1 electron it has, or it could gain to fill this up, which means it has to gain 1, 2, 3, 4, 5, 6, 7 more. Losing 1 is easier than gaining 7 because it's a smaller number. So we're going to lose 1 electron. We're not going to gain 7. After sodium has lost his electron, the electron isn't there anymore. And as we said on the previous slide, he is going to be a +1 charge. Now to show that he is an ion and not an atom, we're going to put him in brackets. And that'll be the ion configuration. Oxygen here, he can either lose the 6 valence electrons he has, or he could gain the 2 missing ones. Gaining 2 is easier than losing 6 because it's a smaller number. So oxygen, after he gains 2, he's going to have the 6 he had plus 2, he's going to have 8. The 2 together, 3, 4, 5, 6, 7, 8. He has now a 2 minus charge because he has gained 2 electrons. Remember, lose electrons, you're going to become positive. Gain electrons, you're going to become negative. And the brackets around it to show it's an ion. So for nitrogen, what will happen? You can either lose the 5 he has, or you can gain 3. But gaining 3 is easier than losing 5. It's a smaller number. So nitrogen is going to have the 5 electrons he had, plus 3, he's going to have 8. First 2 to go together, 3, 4, 5, 6, 7, 8. He's gained electrons, he has a negative charge, and he gained 3, so the number is 3. Put a bracket around it to show that it's an ion. So this is what it looks like as an atom. This is what it looks like when it's an ion. Notice the positive guys end up having no electrons, and the negative guys end up having a full 8 octet.